welcome back, and moving on to synthesis of alcohol method number 4. Now, technically I should have called it 4A, 4B, 4C because we have 3 different reactants. And for some of you that are wondering what the first one might be, it's a ketone, right? This is a ketone. We're not really looking for the actual name, but it's a ketone because this carbon is not attached to a hydrogen. Instead, it's attached to 2 bonds and a double bond O. So that's a ketone. The second member is part of the aldehyde family, and the third member is part of the acid family. Now, if you notice, all of them are going to be tested against a similar reactant. Now, you could use the sodium bromohydride H3O plus or lithium aluminum hydride H3O plus. All right. Now, if you remember from the aldehyde and ketones, whenever you use either this or this, it can only selectively reduce a carbon containing a double bond O. It will not reduce the double bond, straight up double bond. So that's the hint. The NABH4 or LiAlH4 can only reduce a C double bond O and not a regular double bond. And what are we going to do? Well, it's quite straightforward for aldehyde and ketone because we've already done it for the aldehyde and ketone reaction. So I don't want to go too much in depth. So all you have to do is leave the double bond untouched and simply replace the C double bond O with OH and H. That's it. And this is a secondary alcohol. And for those of you wondering, how do I know it's secondary alcohol? I've given an explanation on the very first video on the topic of alcohols, where I defined what a secondary alcohol should look like. And the same deal goes for this one. You write everything the same way until you get to, well, leave this hydrogen also untouched. Again, you're going to replace the C double bond O with a hydrogen and a OH. Good. So this is a primary alcohol. So the rule of thumb here is aldehydes give primary alcohols when reduced. This is called reduction. All right, I've mentioned that as well. Anytime you do reduction, you add hydrogens, okay? And the lithium aluminum hydride and sodium borohydride, they're excellent reducing agents. They reduce C double bond O to a hydrogen and an OH. So all you have to remember is we're adding this to that carbon that was containing the C double bond O. All right. Now with the acid, it's a little bit tricky. All right. What you have to do is you got to chop this off completely. All right. You got to get rid of the OH completely from the picture. It's gone. All right. Or you can think of it another way. Leave it be there. Right. There's all you have to do is you have, instead of it being reduced as, you know, I mean, actually write the product. I think I'm ranting right now. So leave the OHB, okay? And instead of it replacing it with the OH and the hydrogen, you replace 2 hydrogens instead. Does that make sense? Okay. All you got to do is get rid of the double bond O completely and add 2 hydrogens, which means even an acid would result in a primary alcohol. So this is a little tricky. You know, you're going in a smooth sequence where you're doing the same thing for ketone and an aldehyde, but as soon as you hit the acid, you're not actually going to add a OH. Instead, you're going to replace the OH with a hydrogen. So essentially, you added 2 hydrogens to that carbon containing. So leave the OHB. The other method is kind of what I was thinking, but you know, just leave the OHB intact. The way it makes your you know, process of memorization a little easier. Again, this is also part of reduction. So Anytime you see these things, they are reduction reactions. All right. So stay tuned for number 5 and number 6 methods.